Let me go back.
I don't think it is. There
Yes,
it is.
thank you, thank you. So let me just repeat that. So this set, fractions, multi-step problems, it's not something I am gonna go over. I do it when this class is designed for early childhood majors as well. So when you have a lot of early childhood majors, I do this. So we're not kind of responsible for it, but if you're going to be a middle school teacher, you can take a look at it, use it, the answers are in the bottom. Okay, so having said that, I'm not going to give you anything from here on the exam. What are we going to do today? The plan is to work on this packet, fractions 2. These are a little challenging fraction problems. The first few shouldn't be that challenging. Mostly from middle school and high school text, American high school text, and some of the problems are from math contests. They're a little challenging, nothing beyond us. So we're gonna work on some of these. So which ones? We have a lot of problems here, a lot, 54. Are you gonna be responsible for all of them? The answer is no. And we're gonna work on some of these right here. Okay, the plan is to do these. Okay, we're not going to be able to do all of them today for obvious reasons. I think 1, 2, 3 are fairly straightforward, but I will do them. Why would I do them? I'm going to approach them a little differently. I'm going to do them visually. A little bit of explanation why we do things visually. Things are changing. We are moving more towards visual. When you do a lot of things symbolically, middle school students can't follow. And there is a lot of research. If I have a lot of those articles, and someday when I have a little bit of time, I'm going to put them here so that you can read them if you have time, if you're interested. So we're going to do a few things differently. A little bit of background. Go ahead, I'm listening. Did I miss somebody, guys? Okay, that's fine. It was probably background noise. So if you don't understand something, just ask me to stop and I'll be happy to go over it, repeat it, and all those things. So the way we're going to do it, okay, I can do fraction problems on in my Word document. That works a little better for me. So a lot of math teaching is about communication, and if you ever teach college algebra, you will see that some of the things we will talk about will help if you're teaching college algebra or pre-cal. It will actually help. So let me make a copy of this. Okay, so again, your homework problems are going to be right here on the side. I'll do most of these. Okay, some of them are difficult. I may tell you, well, we're going to work on 16 tomorrow. Take a look at it and tell me what you think. If you want to share your solution, it's not a bad way to engage you guys. So I'm going to work on the first one. And this document, I made it for us. So I'm going to push everything down. This will be our notes, all those things. Okay, a little bit of background, guys. Well, let me do it visually, then I'm going to give you the background and you will understand. All right. Excuse me. Okay. All right, so let's read the question. Euler has 3/4 of a packet of cookies. Okay, I don't know how many cookies he had originally, but he has 3/4. He eats half of them and he has 6 cookies left. How many were in the packet originally? So if you read the fractions notes, you will I went over it, but here I won't worry about the notes. Whenever I want to represent 3/4 and 1/2 visually, because I'm talking about half of the same packet or half of the 3/4, I'm going to use a rectangle that is 4 by 2. And you're going to soon see why that's not a bad choice. Okay, so let me see. So I'm going to say this was the packet. How I orient my 2 by 4 rectangle does not matter. All right. And sometimes we do things really fast on the computer, and I don't think it's a good idea when we do things on the board. Just to let you know, I sometimes slow down on purpose, but if you still think I'm going too fast, you have to somehow tell me. So this is the whole packet, okay? The whole packet. Again, why did I choose the packet to be 4x2? For obvious reasons, because the denominators are 4 over 4. The denominators of the two fractions are 2 and 4. That's why. I'm going to change it a little bit. Okay, so let's see if we can do it visually. So, okay, so the question says, Euler had 3/4 of a packet of cookies. So this is what he had. Okay, so I'm going to just go ahead and shade it. How do I know this is 3/4? This is 1/4. This is 1/4. This is 1/4. This is 1/4. So 3/4 is going to be this. Okay, so I'm going to go ahead and shade it. This is what he had. Okay, he didn't have the whole packet. The question says that. Now, what did he do? He eats half of them. So he eats half of this. Let's say he ate this many. Okay, and he was left with 6 cookies. That tells me, excuse me, that tells me this must be representing the 6 cookies. Has to be the way. So I'm going to go ahead and say, okay, if 3 cells represent 6 cookies, and let's use the colors here a little bit, he eats half of them. Okay, so I'm going to say I have 3 cells that represent 6 cookies. I'm going to divide it by 3. I get 2. That tells me each cell has to be 2. Has to be 2. Now, it says how many were in the packet originally. Well, that's easy. And the answer is 4 cells in the whole packet. Each cell represents 2 cookies. 8 cells in the whole packet. Each cell represents 2 cookies. So I'm going to go with 4 times 8 times actually 8 times 2, or 16 cookies. So let's pause there a little bit, see what we think. I mean, it's a little, for some of you, it may be a little too much, I know, but we're going to start with something easy, then we'll do a few that are a little more challenging. So it's actually an American 7th grade problem. And if you just do it with a bunch of numbers, some of your students won't understand it. It's an alternate way to explain things visually. Let's pause here a little bit, see if we have any questions from people.
I'm all set.
Good. Mia, what do you think? Is that okay?
Yes, sir.
Okay, wonderful. So again, a little bit of background because we have, it's a graduate level class. So guys, there was a psychologist. His name was Jerome Bruner. I'm going to type his name here. Again, I'm not going to ask you his name. He was highly respected. He was a professor of Harvard. Okay. This was his work, based on his work, and this is what he said. This is what his research showed, that we learn through inactive. First, if you acted out something to a child, actually it works that way for adults too. Learning takes place at 3 levels: inactive, acting it out. I have 3 marbles. Your brother gave you 2 more. All those things, and then iconic. And the last one is abstract. Okay. Iconic is what we did. All right. So in education, in college, and in school, we tend to jump here. And that's why many of our students are lost. If you can make something inactive, and I do a lot of origami, even I'm 50 plus, even at this level, I have to fold the paper to see what's going on. I can't do it in my head. Once I fold it, I can draw a picture. I'm good, totally see what's going on. And then once I really understand what the picture looks like, I can do a lot of things in my head. That's how actually we learn. And people from Singapore took this idea and implemented it, and their kids do very good. So what the Singapore, there's a famous term called Singapore math all over YouTube. Sometimes we'll watch a clip or two sometimes. It's their kids do very well because they use this principle and it's coming back to the US. Bruner was around in the 60s, 50s and 60s. That's when he did his work. And he wrote a lot of well-known books. He's highly respected. He was a psychologist. And so we'll do a lot of things visually. Of course, when we're doing things visually, we can be inactive too. Being inactive is a little hard because we are far away from each other. But of course, we can say something like, somebody had 2 marbles, their sister gave them 3 more. How many marbles do they have now? I can ask those questions, but we'll be mostly here. Why? Because middle school kids are either here or here. Of course, they'll understand a few things at an abstract level, but not a lot of the things that you guys are trying to teach. So having said that, any questions, guys? Look up your own group. Go ahead. I'm listening.
I do. So iconic and abstract seem pretty obvious to me. And I feel like I understand what an active would be, but I'm not sure. So I want to gain some clarity here.
Sure.
So my guess is that an active is watching someone perform all the steps. And because you're watching, you're having that mediated to you. So that's an initial mediation before a remediation.
Sure. Yes, you're absolutely right. Look,
do I have that right?
Yes, you do. So let me give you a very, very simple example. Okay. So if you're talking to a child, I don't know if you have access to kids. I do.
I have 3.
Sorry?
I have 3.
Oh, good. So I don't know how old.
They're not really kids now. My daughter's starting college next year, but.
Right. So try, if I know, so your daughter is not a child, but when she was very young, if you ask a child, a kindergarten kid, about a concept of addition, they might get it. So you will have to take some marbles, take some pencils, and tell them you have 3 pencils. If you lose 2, take 2 away from her. How many pencils would you have? Once you say that, they will, the concept of subtraction will click. You might have to inactive is acting it out. You might have to act it out. And
I see.
So that's all it means. It's really not that fancy. So you could say with a little older child, if you just tell them, and that's unfortunately sometimes we teach that, we say this is 1/3. We have 3 equal parts. I'm talking about most students, most 5th graders. Actually, this is done in 2nd, 3rd grade. They won't have a lot of clue. But if you say, let's grab a pizza, and I have 3 friends and they want to share it equally, how would you do it? They will draw an irregular picture. Picture won't be very accurate. So it's kind of between inactive and iconic, but if the kid is a little bigger, they will understand. You can even, if you want to make it really more inactive, you can take a little circle, cut into 3 pieces. Take a long candy bar. If you don't want to deal with circles, you can take a long candy bar and say, hey, I'm going to share it with 2 other friends. We have 3 friends. How would you do it? And kids will cut it. I have a niece. She's very young. She used to cut it like this, and she would say, well, they're the same. I understand they're the same size. So that's more inactive. Okay. So the symbol, jumping to symbol, 1 out of 3 doesn't make any sense. And when we do that, students think that 1/3 is smaller than 1/4 because 3 is smaller. They say all sorts of things. And I have seen students who don't understand place value. And there are tons of concrete objects that you can use for kids to understand place value. They would say things like 10 is smaller than 9 because 1 and 0 are both smaller than 9. They don't have the concept of place value, the fact that 1 is here. And you have, I don't know if you have seen base 10 blocks. Base 10 blocks help students see. So this thing is there. This concept that learning takes place at 3 levels is really embedded in our culture. It's not really, but we don't use it. Many of us don't know it. That's why we don't use it. But if you, even in college, when we do a problem, I try to sometimes act it out if it's really complex. You know, we're going to take it from you. And that's why I use a lot of hand gesture, I guess. So
Mhm.
try it. And if you can't really act something out, you can draw it, take a piece of paper, cut it out, all those things.
Yeah, in physics, that's required. Especially in electromagnetism, electrodynamics, we have to either use hand motions or some sort of symbol. Okay. Thank you
Exactly.
for clarifying that.
Sure, absolutely. Absolutely. So, all right, going back. So that's, again, this is not going to show up on your exam or anything. I'll give you math problems. So moving on, and so that's that. Don't save. Okay, back to our, I'm going to save it. All right, so I'm going to work on this. This is not that bad. Again, what we are using, guys, when you're teaching fractions, even in, you don't teach a lot of fractions in high school, but there are tons of high school problems or college level problems that are based on concepts of fractions. So this could actually help a lot. Ruth has a pencil box that is half full. Again, I'm talking about half. I am talking about 2/3. Let's read the whole question. 4 additional pencils in the box. She puts 4 additional pencils in the box. The box is now 2/3 full. So how do we represent this so that more people can understand, just not me and other adults, right? So here are a couple of things I'll do. I really want to understand what's 1/2, what's 2/3. And since I'm referring to the same box, it's a good idea to make my pencil box 2 by 3. Okay, so I'm going to take my pencil box. I'm going to say from the 2 denominators, I'm going to say, okay, my pencil, it doesn't matter if it's 2 by 3 or 3 by 2. 2 refers to the row. Generally, the first number is the row and the second number is the column. Most of us are a little relaxed. We don't care. So I'm going to start with 6 cells. 6 cells. Of course, you can use a strip of 6 cells. Just a long 6 cells will work too. Now, I am going to show you guys how to represent half. Clearly, half will be this. Half of 6 is 3. And I also want you to understand that 2/3 will be okay. So this is my box. Give me 1 second. Okay, so this is my box containing, well, 6 cells, and this is half. Half of 6 is 3. I shaded 3. It doesn't matter how you shade it, which 3 cells you choose to shade. This is 2/3. How do I know this is 2/3? Well, this is 1/3. This is 1/3. Then this is 1/3. 3/3 make a whole. Let me choose a different color. This is 1/3. This is 1/3. And this is 1/3. So I shaded 2/3. That makes sense. All right, now let's go back to the question. Ruth has a pencil box that's half full. Okay. She puts 4 additional pencils in the box and the box is 2/3 full. That tells me this is the background knowledge your kids will have to have, and you have to kind of show them all those things if you're teaching a middle school class. But really what we are trying to say is this. I'm going to write half like so. And I'm going to choose for my half light blue, just to be consistent. This is half of my pencil box. Okay, my main solution. My main solution. This is half of my pencil box, but Ruth added 4 pencils and the box moved from here to here. That tells me this has to represent her 4 pencils. This has to be, one cell must hold 4 pencils. There is no other way around it. So I'm going to say, okay, that line, I'm going to make it my new set of pencils. I'm going to make it green, I guess. So I'm going to say this cell has to be 4. They're asking how many pencils will fit into her pencil box. Each cell is 4. And so the answer is 4 times 6. 4 times 6 is 24. Sorry. I'll go back and show you everything. Okay, so let's pause here, see what's going on. Again, it's a representation of what's going on so that a middle school kid can understand important concepts of fractions and they can solve this very problem. I'll pause here a little bit, see what's going on.
Can you explain the main solution part again?
Sure. So this is half, right, Mia?
Yes.
This is half, and this is 2/3. Half is 3 cells. Okay, and 2/3 is 4 cells. 4 cells represent 2/3. So if you read the question, she added 4. The pencil box was already half full, so these were already there. And she added 4 more, and it turned into 2/3. So to go from 3 to 4, you have to fill in 1 cell, not 4 cells, only 1 cell. So your 4 pencils, Ruth's 4 pencils, must have been that green cell. Does that make any sense?
Yes.
Good, good. So once you know that extra cell represents 4 pencils, you can just say, okay, all cells represent 4 pencils, and the answer is, let me just clear this. Answer is 4 times 6. Now, occasionally, these are not the hardest problems. So again, if you want, you can always say, can you give me another problem? Can we do another problem like this? That's okay. I can also upload some extra practice problems similar to the ones I specifically assign in class. And those problems are going to show up on your exam. So we'll see how things go. If things make sense, we'll move on. If things don't make sense, you want some extra practice, those of you are here. That's one of the good things about coming to class, because you can slow me down. If nobody's here, I'll just record the lesson and do more problems. So do we need extra problem, or we get it? Do we move on? Where are we?
I'm good.
Good, good. And don't be shy. So let's see what the next one is. Okay, so we did 1, 2, let's do 3. Let's do 3. And this document will be here, so I'll keep track. Oh, by the way, guys, it's the thing is kind of in 7 minutes it's going to shut down. If that's okay, let's get out of this session and use the same link really quickly, and we'll work on problem number 3. Okay, see you soon, guys. I'm going to get out of this session.